Hello, I'm Nigel Griffiths. I work in Power Systems Advanced Technical Support for Europe. This movie is an introduction to the VIOS Shared Storage Pool, which is a new feature. We're at Phase 1. Now, the internal name was NextGen, and we're no longer meant to use that because it can cause confusion. The official name is then the VIOS Server Shared Storage Pools, and it's a feature that comes along with the regular Power VM Standard Enterprise editions. In the documentation, though, you have to look for something slightly different. There it's called the Clustered Storage Subsystem, but it is the same thing. Now, the features are provided as part of the regular VIOS server. It's not a replacement VIOS server, it's the same VIOS server that we've been using for a long time now. There's a common misconception. Some customers were thinking they have a VIOS server or they have a next-gen server, but it's not true. It's all the same thing. And there's no additional cost for this. All you need to do is upgrade your VIOS server to this level that came out in December 2010. So it's the 2.2 Fixed Pack 24 Service Pack 1. Now, some people are having a few problems getting up to that level, particularly if you've got very old versions of the VIOS server. It's quite a long path. Don't take any shortcuts or try and combine some of these updates together. That's what I tried, and I actually went wrong, and I had to reinstall my VIOS server. I started then at 2.2. There's also a little e-fix out. There's a little problem with the C and Ether channel issues, so do include that if you're using them. I do recommend that you RTFM, read that website about the VIOS server. It very carefully explains everything you have to do. I've also added some notes on the AExpert blog on how to avoid some of the problems. Initially, I thought this would be more as a Phase 1 technology stunt or a technology for review purposes only, but I've been told that it has gone through the full test cycle at the AIX labs and it's fully supported by IBM. So if you want to use this for real work, then you will get full IBM support for it. Realistically, though, this is version 1. It certainly allows your systems administrators to learn the concepts and the commands. It's actually very simple to operate. There's only 2 commands to really use. And then we can do things like thin provisioning, which can add quite a lot of value, where you can assign a piece of disk and it only actually gets allocated to your client virtual machine when it's actually used. So if you've got workloads where thin provisioning would actually make sense, then this would be a good place to start. In Phase 2, when it comes out, then you'll be able to quickly adopt this extra new functionality, gain some cost savings, some implementation time, and save some money too. Now, there's a whole load of places to go for information on it. I've summarized it here. The VIO website itself has got some information on it. The download site has a README all about these new features. I put that down as mandatory. You really do need to read the README, and particularly the limitations section. I've got a cut down version of that on the next slide, but you need to go and read it in full and think about it. There's quite a lot of information in there. I've got a note there of where the official documentation is. If you go to that link, there's 2 subsections, one for the command line and the other for SMIT. Now, in actual fact, because you'll be using this as the p-admin user, you don't type in SMIT or SMITY, you type in config assist. There's also a movie which goes through the hands-on commands, so you can actually see it in operation yourself. So here are the limitations, and I'm just going to highlight a few of those. Like I said, you need to read them in full. It's only for Power 6 and Power 7 machines and blades. You'll need a CPU in the VIOS server. That's something obvious, perhaps. I think the idea is the minimum is a whole CPU, and the minimum memory for the VIOS server, if you're using the shared storage pools, is 4 GB in memory. Now, in my little test case, I've actually used slightly less than that, but that's the recommended minimum if you want support. You'll also need some fiber channel attached disks. You'll need 20 GB for something called the repository, and then you need more LUNs that you'll use for the actual data in the pool. And again, the minimum there is 20 GB for each of the size of the LUNs. In actual fact, you probably want to use much larger LUNs than that. It says that you're meant to have these LUNs raided behind the covers. That's the sort of normal operation, and there's a few limitations about the name resolution and the host file that you can check yourself. Further down then we see that one of the big limitations, we'll look at this in more detail in a minute, that the cluster of VIO servers has a maximum of one VIO server in this release, and that quite drastically limits some of the functions, but this is just for the first release. The cluster will need an uninterrupted network to operate, so don't do this on some flaky network. And there's a note there that you can't change the host name of the VIO server while it's actually being operated. Further down there's some limitations about things that are not supported. The VIO server that is being used as the shared storage pool manager can't be doing some other things, like it can't be the data mover for live partition mobility, or it can't be the paging VIO server for AMS. And I think most of these things are testing limitations in this first release that will go away later on. There are some things that are supported, so this VIO server can also be doing sort of classic Virtual SCSI or MPIV, or it can be using the Shared Ethernet Adapter sort of workload as well. You can do some MPIO, but not some of the drivers from other manufacturers and things, so again you need to go and check those. And as it's a new feature, you'll see that the CPU utilization is a bit higher than you would expect with your classic old Virtual SCSI devices, because it is basically doing some more. And there's a little warning about the VIO server backup and restore command as well. Like I said, I haven't gone through that in great detail. Go and read that for yourself, and I think that's sort of mandatory reading before you start. Now let's back up a little bit and give us a history lesson so we can see where the shared storage pool fits in. From day one, the virtualized server could give us virtualization of disks by assigning a logical volume that's part of a pool, a volume group in AX terms, to a client virtual machine. So that's the yellow one in here. Or if you have a SCSI, SAS or solid state disk on the virtualized server, you could assign the whole disk to the client virtual machine. Then we came across SANs and LUNs, and again we could take a LUN from a SAN subsystem via fiber channel. That sort of arrives at the VIO server and it sees it as a disk, and that whole disk can again be assigned to the client. Next was introduced this way that we could, in a pool, create a file system, in that we create a multi-gigabyte file, and that file would be the backup resources for a disk in the client virtual machine. Again, the client would just see it as a virtual disk. In actual fact, it's a big file in a file system in a pool. Now that was an important one to mention, because that had the make storage pool command, which created the file system, and we could create a file in that pool with the make backing device from storage pool. And the same command would actually make the connection to the vhost adapter, and so get the data available to the client. We'll be making use of that make backing device from storage pool command again in shared storage pools. Next up in history terms, we had the LUNs presented via NPIV, Endport ID Virtualization. This is the VIO servers looking a bit like a SAN switch, where the packets come in from the SAN subsystem and they're passed straight over via the virtual fiber channel adapter to the client, where the client now can actually see the disk in the subsystem. Now we have this idea of a shared storage pool. Again, we're going to have multiple disks joined together in a pool from which we assign space to our client. And again, note that this is a virtual SCSI adapter in the client. It's nothing to do with MPIV type technology. The client then now has 5 different ways of getting a virtual SCSI disk from various pieces of technology. As far as the client is concerned, they all look exactly the same. It's unaware of how the disk is actually at the back end. Now while we're here, I want to point out that live partition mobility, which is already supported with SAN LUNs and NPIV LUNs, will in the future also be able to work with the shared storage pool devices. Not available in phase 1, but in later phases we will be able to do that. Now if we zero in on the shared storage pool, there are two commands that do the bulk of the work. There's first of all a cluster command, and this builds a cluster and then it assigns the disks to the storage pool. And then to assign space from that storage pool to the client virtual machine, we're using this same make backing device from storage pool command. And this allocates the space for the disk and it connects it to the virtual machine. Of course, it's called shared storage pool because we're actually going to share this pool across multiple VIO servers. Not in phase 1, I have to point out, but in a later phase. So here we'll be able to allocate more space from the same pool to different virtual I/O servers and assign those new disks to the new client virtual machines running on different machines, or some of these VIO servers may actually be on the same machine. Now to operate this cluster we also need communications, the network running across the virtual I/O servers. Now it's interesting to note that with the emergence of the FCOCEE, the Fibre Channel over Converged Enhanced Ethernet, the fibre channel cable may be the same as the Ethernet cable. We could have a combined network and fibre channel infrastructure in our machine. It changes the way you start thinking about this a little bit. Now there is actually no thing called the storage pool. The storage pool is actually implemented as different LUNs inside a fibre channel subsystem. The clever bit, if you like, of joining this thing up is this cluster technology that's actually in the virtual I/O servers. And it's the VIO servers communicating with each other that actually make it into a cluster. And they're cooperating with each other so that they understand who's got which LUN and where it's mounted at the moment, and doing the clever advanced features. Now to allow this cooperation we need something called the cluster repository. This is where all the virtual I/O servers actually save the configuration information. If they all get shut down we can restart it and it work out what's happening. Now in phase 1 we've already hinted at this, that the major limitation is that we can only have one VIO server in a cluster. So what can we do even if we have that limitation? So with phase 1 let's first point out that the prerequisites are quite low. A Power 6 or 7 based machine with this latest version of the VIO server installed. And we can use any fibre channel adapter from any vendor. It doesn't have to be the latest 8 gigabit adapters. Any adapter that can connect to your fibre channel will do. And it can make use of that basic MPIO service too. Now in operation actually it is really nice and simple to use, because you'll assign your LUNs, and I recommend nice big large LUNs because there's a finite limit to the number of LUNs we can connect. And we connect those to the pool, then we don't have to do any more SAN administration. The VIO server administrator then can allocate the gigabytes of space from the pool, and the shared storage pool itself works out the placement of the disks. We can actually see that it's using 64 megabyte chunks of data across all the LUNs that are available to it to spread out the I/O across your SAN subsystems. For the client side, they just see virtual SCSI devices, and they know how to do that. We've known that since 2005. So any client VM that supports virtual SCSI will work just fine, and it'll be unaware of the fact that it's using this new technology under the covers. So AIX and Linux, Red Hat and SUSE and IBM I should all work fine. And of course once we've adopted this technology we're ready for phase 2, where we get a whole set of new features. Now the next major benefit is this thin provisioning. When we allocate space to a client virtual machine, we just say how much the maximum size for this disk is going to be. It's only when the client actually touches or writes to a particular disk block that it'll actually get assigned from the pool. In this case I had the first client virtual machine. I installed AIX 7, it could have been AIX 6 or 5.3, and it can see the full size, the 16 gigabytes that was originally allocated from the pool. If you then look at things like the LSVG command, we can actually see that it thinks it's allocated 5 gigabytes out of that 16. But it's not actually the case. if you go looking, you can prove that it hasn't actually written to all of that 5 gigabytes of disk space. An example is the paging space. It allocated half a gigabyte to that. It hasn't actually used the paging space yet. It's only just installed and started up. There's also free space in the file system, so it created a file system of perhaps a gigabyte, but it might be 50% unused at the moment. And of course you can have things called sparse files, where we have a file, it looks like it's a large file, but it hasn't actually written to some places, and it has these holes or spaces it hasn't been written to yet. So if we actually then looked at the pool, it said that only 3 gigabytes of the pool have actually been allocated. So in this case, we're giving it 16, it looks like it's 16, it's happy using what it thinks is 16, but it's only using 3 gigabytes. 13 gigabytes has actually been freed up. It's sitting in the pool. And another way of looking at this is that instead of every client virtual machine having its own, in this case 11 gigabytes of unused space, all of that unused space is now back in the pool, so we can actually manage that and we can go and reuse that free space. That's okay, provided all the clients don't start busily writing to all its disks and actually then demanding the blocks lying underneath. So we can have to be careful that we don't over allocate the disk blocks. We need to monitor that pool size. And if we start running out of pool, then we have to go and find some more LUNs and bring that into the pool to make sure we've always got blocks to back up the written to disk space. Now I've been using the shared storage pools for quite a while, and although with phase 1 we have to recognise there are some limitations, what can we recommend for how people can give it a try? Well, if you've got a large machine and you can find a few spare CPU cycles, a couple of gigabytes of memory, and you've got a fibre channel adapter at hand, then I'd recommend that you create an extra VIO server to try the shared storage pool. Then you can do this and get the VIO server up to the latest level without affecting any of your other partitions. Now if you're on a smaller machine, maybe you're already using Virtual SSP for the internal disks, and you've got nothing fancy in terms of live partition mobility and MPIV, then perhaps you would upgrade one of your pair of VIO servers at a time, get it up to this latest level, and then you can try some shared storage pools on the same virtual I/O servers. I've already found that the thin provisioning is very useful. I have a tiny little pool of just 40 gigabytes, and I'm sharing that between my 6 client virtual machines. They all think that they have 16 gigabytes of each, rather than the 6 which would be their fair share of the pool. It means that the 1 or 2 of them can grow up to the full 16 gigabytes without me having to muck about with further disk space. Once I have the pool ready, it's very quick to set up, and my 40 gigabytes looks like 96 gigabytes. Now, although we can only have one VIO server in a cluster, we can have multiple clusters with a single virtual I/O server in them. They'll have their separate pool and their separate repository, but we can run them concurrently. Maybe these virtualized servers are on 3 different machines, or maybe 2 of them are actually on the same machine. And we can also share fibre channel subsystem. They don't need to be in separate disk cabinets or anything like that. You can, for phase 1, if you're worried about only having one VIO server supporting a client, you can have 2 virtual I/O servers with their 2 separate clusters and their own separate set of disks, and you present these to the client virtual machine. And for example, for AIX you can use the LVM mirroring to mirror across those 2 virtual I/O servers. Now I need to point out that when we go to phase 2, we'll no longer need this feature because the 2 virtual I/O servers could be in the same cluster and be pointing at the same disks behind the covers. So this is only a short-term idea. So in conclusion then, a few remarks. Make sure that you've read those limitations and stay within them so that you know you're going to get full support. It's very easy to implement. It's just 2 commands really that do the most of the work. There's a few other commands for managing the resources. Go and look at the hands-on movie to see those in operation. The client virtual machines are just seeing a virtual SCSI device, so there's no effect on them at all. That's excellent news. And the thin provisioning gives us an excellent new function for space efficient use of our disk space. Be careful though not to run out of free space in your pool. So here's my call to action. What do I want you to do, feel and think? Well, what I want you to do is to give shared storage pools a try. Start negotiating with your SAN teams to hand over a few terabytes of disk space for you to manage as a VIOS server administrator. I want you to get up to the latest version of the VIOS server 2.2 on all your Power 6 and Power 7 machines. That will mean that when Phase 2 comes out, you can rapidly adopt the new technology. And you don't need to be a rocket scientist to realize that Systems Direct will be the graphical user interface in the future for shared storage pools. It already has the concept of storage pools, so it's going to fit in naturally. I want you to feel impressed about this next wave of big gun virtualization on our big machines. And I want you to think about how this technology can be used to save you as an administrator time, boost your efficiency of the way you operate your disks, and increase the responsiveness to users.